Hi, this is Yuki. Great to get the opportunity to share what we are building and the kind of things that we are pursuing at Sorella Labs. So, just quickly about myself. I'm currently leading a lot of the research and growth operations at Sorella Labs, which is a team that just came out of stealth about like 2 weeks ago. And yeah, we're usually based in New York, but given that I'm Asian, I would like to also attend a lot of Asian events myself. So a bit of a bias there, but yeah. And I'm also Japanese, so I also attend some Japanese events. Anyway, I love Asia. All right, so today I would like to talk about app-specific sequencing, or how app-specific sequencing enables fat app thesis. And just kind of curious, like, so far, is there any people who have heard about this term ASS, ASS on Twitter? Please, if you raise hand. Okay, no one. All right, great. So yeah, it's gonna be a lot of first-time audience here. So great, let's get started. So just for agenda, we're gonna go through like the difference between the FAT protocol and FAT app, which maybe some people might have heard about, especially the FAT protocol side. I'm not sure about the FAT app. And then we'll go through the app-specific sequencing and how future is asked. So FAT protocol thesis is a thing that I believe came out like quite a long time ago. I think it was like 2021 or something, where they kind of described in a y-axis where you have the value accrual, and in the x-axis, I don't know what that is, but then you have like people kind of saying that, oh, protocol is gonna take like huge amount of values, and then an application is gonna only have like very little. I kind of wanted to contextualize a little bit more, because what does it actually mean to have a value accrual from the protocol angle and the application angle, and this is what I think, right? So the protocol would have basically the control over ordering sequencing of the transactions, the data, in this case the DA, and then the execution confirmation rules, so that comes kind of have the consensus aspect. And lastly, you have the network effect, right? Now, what's left for application is like fees. So for like lending swapping protocols, like you have fees. You also have the sort of like the front end branding, which is kind of like what Uniswap is taking advantage of. Now, there are also like a version of like less fat protocol. Now, I kind of inserted the PFOF there because a lot of time, like those applications have a lot of flows, and they can take advantage of the flows by implementing some sort of payment for order flow. And by the way, yeah, PFOF means payment for order flow, where you basically sell the flow to some external parties who may benefit from that flow itself, and then you basically generate some values there. So that's another way of value accrual. Some example of people who is doing this is like, well, I mean, if you consider MetaMask as an application, MetaMask is also doing PFOF essentially with great efforts by Max Resnick. Maybe I was a bit sarcastic there. Anyway, so yeah. The FAT app thesis that we envision here is like this. So essentially, we are trying to make application take control over the sequencing and ordering of their own transactions, and that in itself would also help bring a lot of those value from the protocol layer to the application layer, therefore making the application value accrual fatter, essentially. So that's kind of like the fat app thesis that I'm talking about. So I think the whole notion of like being able to bring sequencing to their own hands also, in essence, kind of like try to help dApps to gain more control and gain more value in itself. So what is app-specific sequencing? In the traditional sort of like PBS landscape, you have application that submits the transactions to maybe the public mempool, maybe the private mempool. And then you have a builder that is picking those transactions off the mempool and packaging it into a block and run the auction, PBS auction, with a relay in the middle as an auctioneer. And then you have a proposer at the end who's like deciding which one they're gonna pick, right? With app-specific sequencing, things would look a little bit different. So there will be also a private mempool, but this private mempool will be application-specific, meaning that all of those transactions that get submitted into the private mempool will be related to, let's say in our case, our protocol, Sorella protocol, right? We call it Anstrom. And then all of those transactions in the private mempool would then flow towards Anstrom network, or I mean, I call it Anstrom network, but in essence, it's just a consortium of bundlers and sequencers who are like doing this like bundling operations and auction operations. So we have a bunch of bundlers in that network. And then after this bundling operations, we will come out with a big fat transactions, which I just call it a Sorella bundle, right? Or you can call it Anstrom bundle, whatever. And it's a big bundle that then gets submitted together with other private mempool transactions, public mempool transactions. The builder would receive all these 3 types of transactions and then consolidate it into a big block, which then goes through the rest of the auction processes via PBS. So that's like a kind of like at a high level, what's the sort of like the application-specific sequencing really means, right? So I wanted to kind of like, by the way, I hope that was clear enough. Like I hope there's like not skipping over too much things, but I want to also kind of like illustrate what's the difference between some of the things that people oftentimes confuse AS with, right? Because when they look at this, they will go like, oh, so you're sequencing your own transactions. It looks like you're like a rollup, right? We get that a lot. Like we're like, oh, you're a rollup. We're like, no, fuck you. We're not a rollup, right? So that kind of just, let's go through like what it actually means, right? So you have rollups, L2s, and it doesn't matter whether it's like a base rollup or sovereign rollups or whatever, all rollups. I mean all rollups, right? So they do execution, right? And they do also do sequencing. For example, base rollup as well. They do execution themselves with executor. I don't know what they actually call it, but let's just say executor. And they do the sequencing on the base layer. But they don't actually send their transaction in the mempool. Remember, they only send transaction directly to the call data that is sequenced, right? But it's a rollup nonetheless, and they do both execution and sequencing, right? Just as an example. Obviously, L1 also does both execution and sequencing. And boom, we don't do execution. Wow, right? Surprise. So yeah, AS don't do execution. And that's the whole point of like application-specific sequencing, because we're confining our sort of like control specifically over the sequencing of our transactions, not the execution. And also, I want to note that once you, as an application, starts doing any levels of execution, which basically means a transaction verification, which basically means you run some sort of state transition functions, you get into a lot of trust assumptions, whether it be that may need to be fixed with the ZK or optimistic fraud proof or whatever, and the shit gets like exponentially complicated, right? Excuse my words, but anyway. So that with app-specific sequencing, what's the benefit of AS for applications? Oftentimes, if you are on like a Ethereum L1, you have the you choose Ethereum L1 because you have access to liquidity on its native execution. You don't need anyone to bridge over assets from one to another, right? It's a lot of friction and a lot of trust assumptions, additionally, to ask someone to bridge their millions of dollars from one domain to another. And we don't need to do any of that. So that's one. And then another thing is, as you expect, sovereignty over sequencing and also the order flow that goes through the applications. So you now have, because you have a sequencing control, you now have a lot more granular control over how you sequence your transactions. In our case specifically, we can also help recapture any MEV and any LVR or essentially those like adverse selection costs to those LPs via the sequencing operations. So we can perform things like batch auctions, and we can also enforce some uniform clearing price within our sequence bundles, and obviously on top of that, any like auctions to recapture those MEV value for the LPs. And lastly, yeah, we can enable order sovereign dApps, meaning that application who has a sovereignty over their ordering of the transactions. Okay, so what about composability? Oftentimes people kind of raise like, oh, composability could be a problem. Maybe some transaction in this like big bundle may not be composable atomically with a transaction from other protocols. And yes, to some extent that is true. Composability is a trade-off that would be made in certain cases like this, because, for example, we don't want all of this like 50, 100 transaction in the bundle to revert just because this guy reverted, right? It's a lot of risk that is carried on with this bundle reverting if you bundle this with XYZ other transactions from other protocols. Because other protocols, I mean, their revert risk is somewhat a little less controlled. So it's not preferred to have this big bundle of like 100 transactions bundled with other transactions and then revert all together if some bad things happens, right? Also, if some transactions outside is touching a very contentious state, and when I say contentious state, it means like states where everyone is trying to get access to. And what are some examples where, for example, if you're trying to arbitrage certain pool because of the pool is like at a price that is very far off from Binance, everyone is trying to access that, and that pool state becomes very contentious, right? So those contentious states outside of our protocol oftentimes would also require competitions between the searchers, market makers, and those bidders, and that results in bid competitions outside of our bundle, and hence why I mentioned about the value leakage in the sense that those MEV would again leak out from the protocol and flow towards the proposers. So how do we fix that? Now, we can't really fix it completely, but we can at least try to mitigate it by using this thing called preconf. Now, how many of you guys have heard about preconf? Raise hand. Okay, all right, good amount. All right, so preconf, preconf is essentially you have preconfirmation of certain inclusion of transactions conditional on some other factors that is specified by the protocol, right? So in our case, we can try to attempt to perform like trying to provide atomic inclusion of transactions without bundling them using preconf. So some preconf implementation, I'm abbreviating that part because there's like a bunch of different versions of preconf designs available today. But let's say we have some preconf implementations that can provide those preconf for inclusion of transactions. Then we can do things like, for example, like, oh, this transaction's X on balancer is gonna get included, doesn't matter before or after, but included, assuming that Sorella bundle is gonna get included. So this becomes like a conditional preconf that helps bring some levels of atomic inclusion for transactions that may want to go together. And when I say go together, I'm not specifically saying that it has to go before or after. As long as it's go together, that's okay. And that's important because for non-contentious transaction, it shouldn't matter if it is before or after, because it's non-contentious. And so you can have an atomic inclusion of transactions that are also non-contentious. And that's very important, because once it becomes contentious, then this shit's not gonna work, right? The preconf, inclusion preconf is also not gonna work if it is contentious. It will become execution preconf, and that becomes a whole another topics of discussion that I'm not gonna get into. What about centralization and censorship resistance? So people have talked about this on Twitter, so I also wanted to address this a little bit more. Essentially, the way that we kind of think about this centralization and censorship resistance is that all nodes that are running Angstrom nodes that are doing this like bundling and auction operations within our protocol would all be carrying their own view of the entire order flow that is coming through the protocol. And also at the same time, they will also be constructing their own CR list, or should I say like a censorship resistance list, or alternatively, people may call it inclusion list, right? Inclusion list. And inclusion list essentially just means that, okay, based on some view of their understanding of the order flow, they see that these transactions have not been getting included in the block consistently, and therefore I want to make sure that they get included in the next block. So that's a list of transactions that they want to get included in the next blocks, and that's a CR list, right? And think about it like this is probably a similar but out protocol implementation version of the fossil, which has been talked about a lot in the ETH research side of things. So this is kind of like how we can essentially enforce censorship resistance while also ensuring that we're not centralizing this application-specific sequencing infrastructure much. And then also, I also like to point out that given the way that we are implementing Angstrom, so this is the Angstrom network. Given that we are implementing Angstrom as such, if you really look at us, like our centralization point would not be the Angstrom node, but rather be on the relay and builder side. Those guys would be at least for a foreseeable future more centralizing than Angstrom network itself, because we're trying to go out, launch at a pretty decentralized setting. So yeah, the point I kind of wanted to make today is that AS is the future, right? We are trying to use and leverage AS to give dApps more power and value. And for the purpose of what we're doing, we want to capture those MEV, capture those LVR, and turn LP profitable and make our dApps more valuable. Thank you.